Right now, something extraordinary is happening about 600 million miles from Earth. The interstellar comet 3I Atlas, officially the third confirmed visitor from another star system, is on a trajectory slicing straight toward Jupiter's Hill radius, the invisible gravitational boundary where the gas giant's pull overtakes the Sun's, calculated at precisely 53.502 million kilometers on March 16, 2026. NASA's own JPL Horizons system pegged the object's closest approach at 53.445 million kilometers, a match so tight, just 57,000 kilometers off, that Harvard astrophysicist Avi Loeb calculated the odds of it happening by pure chance at less than 0.00004, or about 1 in 25,000. But 2 days after Loeb publicly flagged this impossible alignment in late November 2025, JPL updated their model overnight, slashing the non-gravitational acceleration parameter A1 from 1.66 times 10 to the minus 6 AU per day squared down to around 4 times 10 to the minus 7, a reduction by a factor of over 4, some analyses say closer to 6, pushing the projected flyby just outside that critical zone. Here's what most people don't realize. That tweak wasn't just a routine refinement. It came amid a flurry of new data from NASA's fleet of spacecraft, and it quietly dialed back the very anomalies making this object stand out from every comet we've ever tracked. Let's back up and establish what we're dealing with, because 3I Atlas isn't your garden variety solar system rock. Discovered on July 1, 2025 by the NASA-funded Atlas telescope in Rio Hurtado, Chile, the same system that spots potential Earth impact threats, it was quickly confirmed as interstellar by the Minor Planet Center after pre-discovery images from Zwicky Transient Facility, and even the new Vera C. Rubin Observatory extended observations back to June 14th. By July 2nd, it earned the designation 3I, following Oumuamua and Borisov as the third such wanderer, hurtling inbound on a hyperbolic orbit with speeds clocked at 57 to 68 kilometers per second relative to the Sun. That's unbound energy, meaning it came from deep space, possibly the Milky Way's thick disk, making it potentially over 7 billion years old, older than our own solar system. As it swung through perihelion on October 29th at 1.36 AU between Earth and Mars orbits, over 230 observatories worldwide poured in data, revealing a fuzzy coma of dust and ice, hydrogen cyanide outgassing at rates climbing from 1.5 times 10 to the 25th molecules per second to over 4 times that in a week, as measured by the James Clerk Maxwell telescope. NASA mounted an all-hands campaign, coordinating more than 20 missions. Mars Reconnaissance Orbiter snapped images from 90 million miles away, showing the coma clearly, while MAVEN picked up ultraviolet signals of vaporized water ice from 20 million miles out. Ground teams at VLT in Chile and ALMA in the Atacama supplemented with spectra, confirming non-gravitational acceleration, a subtle outbound nudge from ice sublimation or gas jets, quantified in JPL's Horizons ephemeris. The official line from NASA? It's a natural comet, no threat, just serendipity as it heads outbound toward Gemini constellation. But let's think about what that means. Interstellar objects are rare, one every few years at best, and this one's path isn't random scatter. It's threading the needle toward Jupiter, the solar system's gravitational heavyweight, at a moment when the planet sits 783.8 million kilometers from the Sun. Now here's where it gets unsettling. Avi Loeb, the Harvard professor who's been vindicated before on Oumuamua's odd cigar shape and acceleration, crunched the numbers using Horizons data from Davide Farnochia's team on October 30th. That snapshot showed A1 radial acceleration driving a precise course correction, aligning the March 16, 2026 flyby exactly with Jupiter's Hill radius. For context, the Hill sphere formula is h equals a times the cube root of m over 3m, where a is Jupiter's semi-major axis, m its mass, m the Sun's, yielding that 53.502 million kilometer bubble where satellites can stably orbit Jupiter without Sun's tides ripping them away. Inside that, Lagrange points L1 and L2, equilibrium spots demanding minimal delta V to park indefinitely, just like JWST at Earth's L2 or proposed alien probes Loeb muses about. The probability of a natural hyperbolic interloper nailing that edge without intent? Vanishingly small per Loeb's stats. Let that sink in for a moment. From light years away, it hits the mark with 99.9% precision, as if engineered. But this is where it gets strange. Post-perihelion, as 3I Atlas emerged from solar conjunction on October 21st, Hubble-adjacent assets and Mars orbiters confirmed anomalous brightening, faster than models predicted, hinting at controlled emissions or unseen jets. Then, boom! JPL rolls out a new non-grav model November 24th, swapping water ice sublimation for carbon dioxide's inverse square dependence, 1 over r squared. Suddenly, the perijove jumps to 53.587 million kilometers, plus or minus 45,000, now slightly outside the Hill radius. Luminosity data from Hubble-era studies doesn't jibe with CO2 rates, though. It suggests water or something asymmetric. Why the switch, and why so fast? Horizons pulls from global astrometry, yet this pivot came amid a U.S. government shutdown delaying NASA image releases until mid-November, fueling whispers of internal reviews. Coincidence? Or a quiet recalibration to downplay the precision? The question everyone should be asking is, what does the raw data from those 122 initial observations across 31 observatories really show before the model tweak? Loeb points out the integrated drift constraint is tight, but radial dependence near perihelion remains fuzzy since the sun blinded Earth scopes. If you adopt a steeper water ice curve, the flyby snaps back toward the hill edge. And remember, escape velocity there is just 2.2 kilometers per second, trivial for deploying daughter craft. NASA's Planetary Defense Coordination Office insists no hazard, trajectory stable outbound. Yet discrepancies pile up. James Clerk Maxwell Telescope saw HCN production double in days, implying uneven activity not matching uniform ice models. Vera Rubin caught coma growth pre-discovery, constraining nucleus size amid rotation signals that some Fourier analyses struggled to parse without aliases. Deepening the intrigue, connect this to patterns. Oumuamua tumbled without coma, accelerated non-gravitationally without visible jets. Loeb's tech probe hypothesis. Borisov gassed normally, but 3I Atlas? It brightens oddly post-perihelion, aligns with Jupiter amid non-grav nudges, and now data shifts suspiciously. Why Jupiter over Earth or Saturn? The gas giant's mass makes it a beacon, hill sphere vast enough for stealth ops. Some researchers quietly note classified DoD assets might have better tracks, but public feeds get filtered. Timing feels too perfect. Shutdown hits right as perihelion hides it. Data delays pile on, then model change post-Loeb. Why would JPL, with input from ESA's JUICE probe en route to Jupiter, alter parameters reducing anomaly flags by half a dozen-fold? Still classified MAVEN UV wiggles or Mars orbiter pixels, not yet released per recent briefings. Anchoring in science, the official explanation holds water, ice. Interstellar comets ablate under sunlight. Outgassing propels them via Yarkovsky-like effects. Parameters A1, A3, and horizons account for that empirically. Brian Marsden's foundational work on water sublimation fits many comets. NASA's multi-lens view, MAVEN hydrogen signatures, MRO coma shots, paints a dusty ice ball, no artificial signals. Yet Loeb counters. Luminosity overshoots CO2 models, suggesting hybrid or unseen drivers. Radial tweak needed for hill match implies intent over chaos. Contrarians like him invoke peer-reviewed archive preprints on temporal evolution, noting spectral red slope steepening from 21% per micron July 15th to 22.8% by July 25th via SALT and NOT scopes. Conventional science gets uncomfortable here, not because it's sensational, but because the data demands revisiting natural biases. What if this isn't random? Escalate the stakes. March 16, 2026. Juno circles Jupiter. JUICE arrives later. Psyche flyby possible. Prime vantage for spotting ejected objects at L1, L2. Escape at 2.2 kilometers per second? A mothership could seed satellites there indefinitely, spying on our system without fuel. Implications for humanity? If natural, just cosmic tourism. If not, first evidence of extrasolar tech probing the king planet first. Why? Radiation belts? Moon's secrets? Our tech footprint? Reality bends. Are we the anomaly or watched? But we haven't even gotten to the strangest anomaly yet. The 7 potential jets firing post-perihelion that some YouTube trackers swear turned up in raw feeds before processing. And why did NASA's briefing dodge Loeb's math entirely? Hold on, because the layers go deeper.
You remember the hook. 3I Atlas, the interstellar comet discovered July 1st, nailing Jupiter's hill radius with eerie precision until NASA's JPL Horizons tweak dialed it back just enough to call it coincidence. Avi Loeb's math showed odds under 1 in 25,000, non-grav acceleration slashed post-callout, data delays amid shutdowns. But we haven't even gotten to the strangest part, the mounting anomalies that make the official comet story feel like a placeholder. Number 1. The post-perihelion jets. Raw feeds from Mars Reconnaissance Orbiter around November 10 hinted at 7 discrete plasma bursts, visible before coma processing smoothed them out, patterns echoing Oumuamua's thrust but amplified. Number 2. Luminosity spikes. Hubble's UV spectroscopy, November 2025, caught sulfur-to-oxygen ratios off by 15%, and brightness jumped 2.3 magnitudes faster than CO2 models predict, suggesting pulsed emissions rather than steady sublimation. Number 3. Age mismatch. Backward integration places origin in the thick disk transition, implying billions of years exposure, yet surface fresh, no radiation darkening expected for natural ice. Number 4. Ecliptic alignment. Tilted retrograde 5 degrees, hugging planetary plane like it followed beacons. Probability for random interloper under 0.1% per Monte Carlo sims. Number 5. Perturbation preview. Mars flyby October nudged it 0.2 kilometers per second, but Jupiter's March 16 window looms with delta V potential flipping outbound path 10 degrees. Number 6 gets uncomfortable. The second trajectory shift. Just days ago, November 28th, JPL refined again post-Mars orbiter triangulation, edging perijove razor-thin outside Hill sphere. Yet Loeb notes if you factor unmodeled transverse A2, it dips back in. Number 7. Spectral evolution. ALMA and VLT data show red slope steepening 1.8% per week pre-perihelion, stabilizing post, like adaptive camouflage shedding layers. Number 8. HCN overproduction. James Clerk Maxwell Telescope logged 4.2 times 10 to the 25th molecules per second, double Piers, implying exotic volatiles or engineered catalysis. Number 9. No tail asymmetry. Comets spin and fan tails ragged. This one's symmetric, constraining nucleus to under 1 kilometer diameter, rotation period evading clear Fourier peaks. Number 10. The Gemini exit. Outbound vector pins origin precisely, not random halo, but targeted fly-through, odds stacking to 0.001% natural per dynamical papers. Now here's where conventional science squirms. Some researchers are quietly asking, what if it's not natural? Not screaming aliens, but an extrasolar probe on reconnaissance, trajectory sculpted by propulsion to sample Jupiter's realm, magnetic fields, moon biosignatures, helium rain. Loeb posits deployment at L1, L2, low-energy orbits for long loiter sentinels, delta V budget fitting thin film sails or microthrusters. Probability calculations? Chain the alignments. Hill hit, plane hug, jet timing, and coincidence craters below 10 to the -6 per independent sims. This isn't fringe, it's dynamical astronomy questioning priors, like Loeb's Galileo Project radar sweeps for fragments. Official pushback cites outgassing, but ignores luminosity mismatches and jet discreteness. Data we know for certain shows quirks. What we don't know is the intent. The cover-up angle simmers subtly. Why the government shutdown October 15th through 20th, delaying MRO/MAVEN releases until November 19th. Internal reviews held Hubble near-spec full spectra,
promised December, still pending. JPL's batch queries log anonymous pulls spiking pre-tweak, but no audit trail public. ESA's JUICE, inbound Jupiter 2031, shares tracking yet omits Loeb models in joint briefs. Why dodge the Hill precision in NASA FAQs, calling it routine, sans math? Not accusations, just why certain data lingers classified, like DoD infrared from Sibir's SATs potentially resolving nucleus spin. Historical echoes, Oumuamua data embargoed months, Borisov spectra selective. Patterns emerge when you connect dots.
Think about what that means for our place in the cosmos. If 3I Atlas is geology, fine, another data point. But if engineered, humanity's not alone. We're probed, cataloged, perhaps benchmarked against our emissions. Jupiter first shields our inner worlds, tests outer defenses. Existential shift, reality's not empty void but trafficked highway. Questions of Fermi's paradox flipping to they're here, selectively. We're part of something vast, intellectually curious adults peering beyond veils, skeptical because narratives falter under scrutiny. Stakes? Redefine SETI from passive listening to active forensics. Don't close the book. March 16, 2026. Juno eyes the zone March 9 through 22, potentially spotting ejecta. Psyche outbound, might glimpse outbound ghosts. Watch the skies, track horizons updates, demand raw feeds. Keep asking, why the tweaks, the delays? Is the probability natural or nudged? This pattern, once seen, lingers. What happens next could rewrite everything or confirm the quiet watch. Stay vigilant.